Hello, I'm Pavel from INS. I'm going to talk about the deployment pipelines and how to distribute and secure them. So the traditional deployment pipeline that most websites use is that there is a GitHub repo, you push some code, your web app gets built and compiled to a bundle, then it's uploaded some kind of a cloud service like Vercel, and then once the deployment finishes, it points to a new version. This is a pretty standard setup, but also quite fragile. Even before you deploy your website, there is a risk of a supply chain attack happening when your dependencies are being poisoned and you don't even notice that. Your machine could get compromised. The cloud service that you're using might have an outage for many hours, for example. There is without any fallback. And even once you get your website deployed already, you are still at risk with the DNS. All kinds of attacks with it, hijacks, social engineering, takedowns, and so on. Only last year, there has been a couple of long-running outages with the major cloud providers that all those front-end services depend on, from Cloudflare to AWS to Azure, all of them. And they have affected many websites that were unavailable to users for hours. And one of the recent plagues of Web3 is UI hacks. Just last year, there was a huge, actually the largest crypto hack in history with the UI compromise where developer's machine was compromised and malware has been shipped to the front end and sat there for 2 days completely unnoticed. As well as also DNS attacks that resulted in loss of over $1 million and repeatedly happen where a malicious actor contacts the registrar, pretends to be the owner of the domain, and then takes over the domain. But it doesn't have to be this way. Frontends should be verifiable, meaning that all the content that you request is the actual one that the content that you requested is the same one as served, and the hashes match the files. All the updates should be transparent, and you should be able to roll back to any previous version at any time, and you should see who made the update and to which version. And it should be possible for both users and developers to roll back, not only to developers. And the access should be distributed. It should not depend on a single CDN or any other point of failure. And there should be multiple ways to access the same website. For example, through multiple gateways or through browsers that would fetch content from distributed storage and then locally verify the validity of the content. Actually, we already have the technology to achieve that today. One of them is ENS, which serves as a universal web content pointer, meaning that ENS domains map to content hashes similar to how DNS maps to IP addresses. And ENS also provides an on-chain history of all the updates where you can see who made the update, at which point, to what it has been changed to, and you can see all the previous versions and open the previous versions at any time as long as they're accessible. Swarm and IPFS provide distributed storage for those websites, so it is also possible to easily replicate the content as many times as you would like to, have as many copies of the content, so in case one of the nodes or providers goes down, you still have a bunch of copies laying around. All the content on both IPFS and Swarm is content addressable, meaning that all the hashes are the same for the same files, so that you can actually very easily verify the integrity of the content, that the one that you requested is the same one. And Safe also allows to enforce manual reviews before you update your ENS name, so that it's not just a direct update, so in case like there is a compromise of an Ethereum signer owning the name, your ENS name is hijacked as well. So Safe protects from that, requiring a manual approval from multiple parties. And it also enforces reviewing the transaction before you actually make the update. So how could it all be put together? With Omnipin. I have built this tool a couple of years ago, and the way it works is, so you have this Git repo, you push some code, but instead of the bundle being uploaded to one cloud, it's uploaded to multiple providers at the same time in one go, and that way you have multiple replicas automatically, you don't have to do it manually. After the deployment finishes, the transaction is proposed to a safe. You sign the transaction, and then your website now points to a new version, and it's all done in one single command. So it's not only just a deployment tool, it also protects from a number of attacks, thanks to the infrastructure that it uses, mainly ENS, because ENS register updates are governed by the DAO instead of how like registers, which are mostly private companies, where they instead decide privately how to change their service. The names are permissionless, meaning that you can manage them yourself at any time. You don't have to depend on a specific provider or a service. All the records updates are transparent. You can see all the changes, and all the updates require manual review. And you can always replicate anybody else's front-end or your own as many copies as possible. And websites deployed on Omnipin are also accessible through multiple means. There is plenty of ENS gateways, both that are universal for multiple types of storage and also like IPFS specific or SORM specific. And there's also a couple of browsers that support ENS resolution, which you can also access websites deployed on Omnipin with, such as Brave and Freedom. There are already a couple of projects using Omnipin, well, DNS itself and the docs, a project called WalletBit, which is like an index of all the wallets, and they use Omnipin to deploy their website on ENS. I actually initially built this project for Lido, so they have a mirror, IPFS mirror of their staking UI there as well. Yeah, and now I'm going to show a simple demo of just deploying a website on Omnipin. I'm going to be using Swarm that runs on my VPS, just a node, so that it's very easy to showcase demo. So I have an HTML file here. Yep, just pretty boring, but just gonna, sorry. Yeah, I need to load the, okay, I just loaded the environment keys for the signer so that I can propose an update. So yeah, it already deployed it. So if we just click the link, yeah, it already deployed the page, but it's just the Swarm hash, like it's not an ENS name. For ENS name update to propagate, I need to go to the Safe app. I need to connect to my wallet. Yeah, so here's the update. So I can see here what actually I'm signing, the name hash of the name, and the encoded content hash, but it's possible to decode it, so you can see what actually you're signing. And now I'm going to sign an update. Okay. Yeah, so now ENS is updating. It's going to take some time. Yeah, okay, it's basically live already. Now let's just try to change the page to another one. Yeah, now there's another page, so let's just run a redeployment. Okay. Cool, so yeah, now it's already live on Swarm again. Yeah, so this is another page. Now let's see if we have a new update for ENS. Yes, it's already queued. Let's confirm it. Let's see, yeah, everything's good. Now let's execute the update. And the transaction is processing. So shortly after, the update should be available. And it's been indexed now. ENS gateways cache responses, but it should be available in a couple of moments with the new page. So yeah, it's going to take some time, but yeah, anyway. So how it works, the demo is I have a local node running for Swarm, but it could be an IPFS node as well. Yeah, and it just pings the node, and then I use a postage batch, which is like a storage quota, so that I upload to the network immediately, then propose a ENS update to the safe, then approve it, and yeah, but it still will take time. But either way, the content was already live on the Swarm network. It's just the ENS gateway is just caching the response. So yeah, that's pretty much it. But 1 second. Yeah, so you can read the documentation for OmniPin or try an agent skill, so to ask your Claude or any other AI agent to try to deploy it, the website with the OmniPin. And thank you for listening. And
okay, thank you for speech. Do we have any questions to the author and speaker?
sorry, I didn't hear. The costs of these types of deployments aren't high. No, actually updating the content hash costs like maybe a couple cents on mainnet right now. And the gas is pretty stable, so it's unlikely that there's going to be like cost spikes for updating ENS. It's very cheap now. It was a problem like maybe 3-4 years ago when gas was unstable, but after EIP 1559, gas got very stable, and there have been consequent network upgrades, which made it basically very predictable of how much gas costs. So yeah, it's actually not very expensive. Like for example, I have a safe with like $15 on it, and I've been using it for my website for like 2 years, and I haven't even spent like $2. So yeah, I would say the major costs are not from the updating ENS, but from storage. Like you either pay an IPFS cloud service for some subscription, or if it's on Swarm, you pay with the BZZ tokens, so around like $1, maybe $2. So yeah, that's where most of the costs come from, not from ENS. ENS is actually the cheapest component of them all.
Thank you. Do we have any more questions? Okay, if no, thank you for your speech. Let's say thank you to our author again. And